Previously, we had looked at credit default swaps and just had an basic introduction. Here, I was trying to outline the timeline based on a very simple minimalist type credit default swap structure. And we had identified that the level of default was 2% per annum. How that actually translates, though, is a bit different, because we would have a survival probability, right? Survival probability that would, in essence, be if the probability default in 1 year was 2%, then the probability survival to the end of 1 year would be 1 minus that 2%. And you could only default in year 2 if you had survived year 1. So in a sense, the level of default here in year 2 would be equivalent to 0.02, will dollarize by hitting F4, multiplied by the survival probability in the preceding year. So the probability of defaulting in year 2 would be less than 2%, would be 1.96%, because the default here would have implied you must have survived here. And again, if we want to then update our survival prospects for year 2, we would take again 0.98 multiplied by itself. Okay, so we would have this multiplied by itself again, and I lock the cell reference. Okay, so we could say F4, 98% probability of surviving, but to survive year 2 you would have had to survive year 1. And then we can pull both of these down together to look at the evolution of survival over the period. So if there was a 2% level of default each year, right, conditional on no earlier default, then the probability of surviving year 1 would obviously be 1 minus 2%, right, which is 98%. So probability of surviving year 1 is 98%. The probability of surviving up until the end of year 2 would be 0.98 by 0.98. Now this is a little bit, the logic here is a bit like if the probability of getting ahead as opposed to a tail in a coin toss was 50%, and we had 2 iterations of that event, then the probability of surviving, the probability of getting 2 heads would just be the product of the 2. So 0.5 multiplied by 0.5 would give us the probability of successfully getting a head followed by a head. And again, the probability of survival is 98% 1 year, but the probability of surviving 2 years then would be the product of 0.98 by 0.98, and the probability of surviving year 1, year 2, year 3 would be 0.98 by 0.98 by 0.98. So I'm just taking, if you like, the 98 and updating, multiplying by the last probability of survival. And so by the time we get to year 5, the probability of surviving to year 5 would be this 0.9, 0.39, so on. Okay, and the probability of default each year, it's at the margin, it's declining, relatively speaking. Okay, so let's take away this coin toss example. Now remember, the reason why this is important to understand is once we set out our example here with the buyer paying S each year for 5 years, they only pay if they survive each iteration, each year. So we, in a sense, the chance of paying S in year 1, right, is really the probability of not defaulting. It's the probability of surviving. So although we commit to pay S each year for 5 years, if we think of the buyer side, let's think of the buy side, okay, payments, then the buy side payments are dependent upon the probability of surviving each year. So the S, for instance, we don't know for sure S is going to be paid at the end of year 1. All we can say is that there is a 98% probability that S will be paid year 1 and 96% probability that S will be paid end of year 2, end of year 3, end of year 4. So the fact that there's some possibility of default means we're not guaranteed this S payment, and that somehow has to be reflected into the buy side payments, right? If we're thinking of the buy side here on the credit default swap, there is no guarantee that they will pay 5S over the 5 years. What we have is there are these survival probabilities, schedule of survival probabilities, and that must be reflected in terms of the value of the S being paid in a kind of risk neutral setting. So the buy side payments of there is going to be 5S paid, conditional on no default. In addition, when we look at this as a present value type exercise, normally with present value type, when we look at fixed income generally, we have to apply a discount factor reflecting what? Reflecting the time value of money. And the time value of money here, the zero rate is flat at 5%. That means for year 1, year 2, year 3, year 4, year 5, the rate of interest that would apply, or the discounting, would be at a level of 5%. Okay, so 0.5 to the power of the time period, multiplied by the time period. And we put that here. Okay, so the present value, the discount factor for 1 year would be 95%. Over 2 years, okay, so I've got to dollarize, go back and dollarize the interest rate, F4, and then we'll drag that down. And again, and again. So in what we have is on the buy side, yes, S is going to be paid each year, conditional on survivorship, but we also must discount those S to reflect present values. And when we take the adjusted, we can, I'll just reformat this. And justify. Click OK. Okay, so that saves a little bit of space. And then in addition, we need to put in, okay, so we need another column. And we say present value, PV, of expected payment by buyer. Okay, and maybe stretch this out a little bit, reformat, and widen again. Okay, so we take the product of the survival multiplied by the discount factor. Okay, and we pull this down again. And again, we probably have come too many decimal places here, but we'll just leave for the moment. And again, S. We could think of each of these as, instead of being sure S is being paid, right? S is being paid across here. In a certain world where there was no discounting, we would say the buyer will pay 5S. In an uncertain world where we have a default, where we specified that the probability of default is 2% and the discount factor is 5, or the discount rate is 5%, then in taking account of default and taking account of present value, the buyer is paying 0.93 of S year 1, 0.86 year 2, 0.81, 0.75, 0.7. So the effect of the discounting and survivorship is quite dramatic, and the buyer doesn't pay the full 5S. In reality, in present value terms, adjusted for probability of default, the buyer is paying the equivalent of, well, what? Just the sum of that. Let's sum it up. Sum those 5 figures together is paying 4.07S. Okay. So we could imagine here that if the notional principal of the reference asset was $1, €1, let's go $1 for the moment, then the value that the buyer pays is 4.07 S, where in the event of the full period of 5S is paid. When we take account of discounting, when we take account of survivorship, the commitment to pay 5S actually is only worth 4.0S, and that would be 4.07% of whatever the value of the reference asset would be. Okay, so what we have here is a low probability of or a high probability of a small payoff. We're paying small amounts each year for the 5 years. So a high probability, the probability being dependent on survivorship, high probability of paying a small amount. In addition, there's also some accruals here that I'm going to ignore for a moment, that also the buyer has to pay, but we'll have a look at that momentarily. What about the sell side? On the sell side, right, what we have, sell side, is really a low probability of a high payment, right? So if you think of the seller, normally the seller in these type of credit default swaps, they're not triggered. There isn't a trigger event. Irish government bonds don't default, and the seller just collects those 5S, even though when we express in present value and adjusted for survivorship, that amount is not quite 5S in present value terms, it's more like 4S. But what does the seller give in return? Well, it gives a guarantee that in the event of default on this side, the seller will commit to paying whatever amount the reference asset is underwater. So if the reference asset is trading for 40 cents in the euro or 40 cents in the dollar, the seller then is prepared to make up the other 60 cents. So what we really have is a low probability of a high payment, right? So if it was $1, 60 cents would have to come across, but the chances of that occurring are small. So low probability of high payment. The buyer, in contrast, has a high probability of low payment.